going to do a video on Eulers Line, and I'm hoping I don't mess this up. So we'll see what happens. The first thing I want to do is I'm going to click on Polygon, and I'm just going to pick any 3 points. And it doesn't need to be any special type of triangle, but so I'm going to pick these 3, and the way to make a polygon is you have to go back to the original point, you click on it, and you get this. Now, I don't actually want the sides, so I have A, B, and C, and I go to here, and when you click on this, you go to settings. Let me do that. Let's see. I don't want to show the label, and I think that's the key here. I just don't want the label shown, but it does bring up an interesting point. If I want, I could do name and value, or I could do caption and value, but I have to put in a caption, but I actually don't want any of that. I don't even want the name, so I'm going to get rid of this. So what I'm going to do now is this. I will leave ABC there. In order to do Eulers Line, I need to know a couple things, and one of the things I need to know would be the midpoint. So if I wanted, I could go to here and I could find out what the midpoint is, and it says select 2 points or a segment. So I select that, and there's my midpoint. Select this, there's my midpoint. Select this one, and there's my midpoint. Now, if I wanted a segment, I could very easily just say, well, to find my median, I'm going to go from there to this point, and then I want my median here. I'm going to go from here to this point, and my last median is from here to this point. This gives me my centroid, and the interesting thing about the centroid is that the centroid, oops, that's not where I want that, forms a nice, interesting ratio of from A to G and G to E. It should be 2/3 to 1/3. And what I might have to do is attach a point. So let's see if I attach the point to there, and now it's attached. And once again, if I want to check this out, I'm going to try not to make this too long, distance or length. I'm going to go from A to G, and then G to E, and if I were to double this, I would get AG. So that looks pretty good. All right, now that's not really what I'm after. What I was really after was I wanted to find the point G, because that's my centroid. So what I'm gonna do is I'm gonna now get rid of these lines, and when I do that, hopefully I don't get rid of G as well. I may. Oh, there goes G. So that could be problematic. So what I'm going to do is I'm not going to get rid of the line itself. I'm going to get rid of, I'm going to get rid of, these allow us to see the lines, but they still exist. Before I actually got rid of that line, and now it's gone. So that was the centroid. Now if I want to do the altitude, what I would do is I would say I want a line, and it has to be perpendicular to the base. So it says select a point, and the line I want perpendicular to. So here we go. So now I'm going to find the altitude from B to AC, and you can see that. And then I'm going to find the altitude from C to line segment AB. And not if I don't actually click on it. So once again, this is kind of important. I'm going to click on C, and I have to make sure that my arrow, my cursor becomes a hand. And there we go. And once again, you can see I have my 3 points of intersection. I'm going to get rid of this. That's my orthocenter. And now the last one is the perpendicular bisector of each line. So it says select 2 points or 1 segment. So I'm going to say, all right, well, I want the perpendicular bisector of this line. No surprise there, because it bisects it, so it should go through point E. And it gets the bisector here, it goes through there. I want the bisector here, it goes through there. So now I'm going to get my point, and I'm going to put my point right here. It looks like E, the letter E might be in the way, so I'm going to move it. I grab that, I'm going to move it down, grab my point, and select it. There we go. Now I get point I. Now once again, I don't want those because they're, I do want the point. I'm going to get rid of these. And now in order to find Euler's line, it looks like what I have is, that was silly. I have H, G, and I. So I'm going to get rid of D, E, and F because I don't want this messing things up. I'm going to get rid of my polygon, and I'm actually even going to get rid of these 3 points right now. So all that's left is H, G, and I. I'm going to go to best fit line. It says select several, so there we go. And now you can see it gives me the equation of Euler's line. It goes through all 3 points. It's y equals negative 4.88, x minus 3.58. There is 2 small things I want to show you left. None of them have to do with that. The first thing, which I think is kind of neat, is so get my polygon there, and get my circle, and I start here. It should connect all 3 because that's what the circumcenter does. It will connect all 3 vertices, and that will be the center. If I want to do, now let me get rid of Euler's line. If I was to do the angle bisectors, which once again I could just do by this, we get something else, but I'm going to show you I can do angle bisectors. If you want to do an angle bisector using the old whatchamaflip, construction way, you can still certainly do that. The only thing is I would have to make sure I use the same circles. Yes, I'd have to make sure the circles were the same. So I'm not going to do that because it's going to take too long. But one of the cool things about the angle bisectors is when you do that, you're going to get the incenter. And if you do the incenter, something kind of neat happens. So let's say, so select 3 points or 2 lines. All right, so select this point, or this line, and this line. There's my angle bisector. I'm going to select this line and this line. There's my angle bisector. I'm going to select this line and this line, and there are my angle bisectors. It looks like here's my point right here. I'm now going to hide these once again. Hide these because the only thing I really want is point L, and this is kind of neat. This is what the incenter does. I start here, I pull it out, and it will touch all 3 points. And I wonder what happens if I pick this. Alright, so you can see it's showing 2, so when I move them, if I move them close enough, I might have to enlarge my screen. It's really what I need to do. But I want it to be one and the same. And I guess that's gonna have to be close enough. I'm sure I could probably actually do it using this function, but I feel like this has gone on long enough. In any event, I hope this has been useful, and it's kind of cool. So that's how that's one of the huge advantages to using the algebra screen. Thanks.